All right, so let's practice a few more on this worksheet here. So find the open intervals on which the function is increasing, decreasing, locate all relative extrema. Okay, well, it all starts, there's no discontinuity, so it starts here with the derivative. So that would simply be 6x squared plus 6x minus 12. Let's factor out a 6, x squared plus x minus 2. So we get 6 times x plus 2, x minus 1. All right, then we'd be looking for critical numbers. So the derivative equal to 0 or the derivative undefined when the original function is defined. For the equals to 0, we would have it at -2 and 1, and undefined nowhere. Okay, so that tells us we have to put -2 and 1 on our number line chart. All right, -2 and 1. Then we're going to go back to our nice factored form here and use that to plug in some numbers. So again, if I go somewhere in this interval here, so maybe like -3, and I go back and start plugging it into the derivative, the 6 isn't going to change its sign, so I can forget about that. -3 plus 2 is a negative. -3 minus 1 is a negative. 2 negatives multiply to be a positive. All right, in the middle here somewhere is 0, so I'll take 0, plug it in. Again, I get 0 plus 2 is a positive, and 0 minus 1 is a negative, so it's negative in there. And if I say take 2 in the last region there, so then I will have 2 plus 2 is 4, and 2 minus 1 is 1, so that's positive, positive, positive there. Okay, so that tells me, since the derivative is positive in this first region, f is increasing there. Since the derivative is negative in the second region, it's decreasing there, and the derivative is positive in the third, f is increasing there. That also tells me about what's happening at 2 and 1. Because, -2 and 1. Before -2 it was increasing, and then after it was decreasing, and that means it must have topped out there. So that's a relative max at -2 something. And at 1, we had it decreasing before and increasing after. It must have bottomed out there. Relative min at 1 something. Okay, so I have to go back to my original function and find out some values. So for -2 and 1, now if I plug -2 into this function, you're going to find out you get 20. If I plug 1 in, you're going to get -7. So I have -2, 20, and 1, -7. All right, summarizing, we'll list where f is increasing, where f is decreasing, where we have some relative max, and where we might have a relative min. All right, increasing, it was increasing on -infinity to -2. It was end 1 to infinity. It was decreasing on -2 to 1. It had a relative max at -2, 20, and a relative min at 1, -7. And there's basically all the information we wanted. All right, let's try another. f of x is x minus 1 to the 2/3. Still no discontinuities. There isn't any place where that's undefined. So let's go to the derivative. That's 2/3 x minus 1 to the 2/3 minus 1, so a minus 1/3. So that's really 2 over 3x minus 1 to the 1/3 if I want to see no negative exponents there so I can figure out some things. All right, f prime equal to 0, f prime undefined, where f was defined. Okay, so where's the derivative equal to 0? Okay, go back to this derivative we have here and realize the numerator is 2, so it's never going to be equal to 0. Now, is there any place where f prime is undefined when the original function was defined? Yes, at x equals 1. Look, that makes the denominator 0 in the derivative, but the original function was perfectly fine at 1. So that's a type that we would get the critical number from the derivative being undefined. All right, so we have that only that one number to put on the derivative chart here. I should label it. So that's the derivative chart there. And let's see what we have. So go back to the derivative, plug in a number less than 1, so 0, say, but the 0 minus 1 in the denominator is minus 1. Cube root is still negative, so you're going to get a negative there. If you plug in something bigger than 1, say 2, 2 minus 1 is going to be a positive, and the cube root is still positive, and so you're all going to have positives there. So that tells me that f is decreasing there, f is increasing there, and it also tells me what's happening at 1. So it was decreasing before and increasing after, so it bottomed out there, and that's a relative min at 1 something. And again, if I go back and figure out, take my original function, plug in 1, then I would just get 0. So that relative min is at 1, 0. And so I have everything I need. So let's see, where is f increasing? Where is f decreasing? Any rel maxes? Any rel mins? All right, increasing on 1 infinity, decreasing on negative infinity 1. Relative max, well, there weren't any. Relative min, 1, 0. And there you go.